In May 2011, just before the retirement of its shuttle fleet, NASA committed to an additional flight carrying an impressive 8-ton particle detector to help answer the fundamental question, what is the universe made of? 90% of our universe remains undetectable and incomprehensible. We simply do not know the answer. Since it has been attached to the International Space Station, or ISS, the €1.2 billion Alpha Magnetic Spectrometer, or AMS, has been working perfectly in space under extreme temperatures. Before launch, the European-built instrument was tested extensively at ESA's ESTEC Center in the Netherlands for thermal vacuum and electromagnetic compatibility. Then, once launched into orbit, 4 astronauts, including Italian ESA Roberto Vittori, carefully installed AMS onto the station. Immediately, this Hubble telescope of cosmic rays started collecting and analyzing millions of high-energy particles shooting from remote parts of the universe. These pristine cosmic rays, detected above the Earth's atmosphere, could lead to new physics.
We have now close to 17 billion events, and how to measure every event very accurately and takes time because the detector is a very complicated detector.
These millions of invisible events are also used to precisely calibrate the 6 AMS detectors in order to fully exploit their sensitivity and search for the most rare events of the universe. AMS's huge magnet, 4,000 times more powerful than Earth's magnetic field, and its detectors sift millions of particles per second to measure their mass, velocity, direction, and to identify them. The analysis of their spectrum could help our understanding of the unexplained disappearance of antimatter in the universe and the mysterious dark matter that prevails in the cosmos. Even if the 200 or so AMS physicists from around the world are far from publishing their exciting results, they could already be obtaining some tantalizing hints, like the challenging detection of thousands of elusive positrons, which are the antiparticles of the electrons.
Calibration of positron is important because when you have dark matter collision with another dark matter, you produce excess positrons. So the characteristics of the excess positron tells you what's the origin of dark matter.
The minute calibration of AMS is at the heart of potential groundbreaking discoveries. AMS is fully controlled from the Payload Operation Control Center, or POC, at CERN near Geneva, where international teams are monitoring the continuous flow of AMS data 24 hours a day, 365 days a year. There won't be any preliminary results. The top physicists of 16 countries involved in AMS, under the leadership of Samuel Ting, have been separated into 2 independent groups to make their common conclusions more robust.
When should I publish? My answer was, and still is, as late as possible. For a simple reason. It took us 17 years to build this detector, and given the difficulties and the cost to build this detector, I think in the next 50 years, I doubt that anybody will be foolish enough to repeat such an experiment. What I believe, what I do not believe, is not important. We have many hints, right? But it takes a long time to collect these hints together to form undisputable facts. So it will take time.
The first cosmic ray telescope has no deadline or schedule, but it has started its long process to throw new light on the mysterious universe in which we are bathed.